What if the most attentive astronomer in history wasn't human? Not Herschel, not Hubble, not even a Nobel-winning astrophysicist, but an algorithm. Scientists at NASA's Frontier Development Lab, in collaboration with Microsoft and IBM, are developing self-learning systems that can predict the strength and scale of solar storms. If successful, these systems could be used not only to assess the climate and habitability of distant planets, but also to locate natural resources. The lab was founded by New Zealand entrepreneur James Parr, who was inspired by the Obama-era Asteroid Grand Challenge back in 2013. Parr approached NASA with the idea of combining cutting-edge AI technologies with planetary defense efforts, projects aimed at protecting Earth from asteroids and other space hazards. According to Parr, artificial intelligence is still the most underrated tool in the hands of astronomers. Artificial intelligence is also helping scientists discover new planets. The Kepler Space Telescope, equipped with an AI-based algorithm, was launched in March 2009 and operated for nearly a decade. During that time, it helped astronomers identify over 2,600 exoplanets. In late 2017, it even helped discover a system similar to our own solar system, revealing the planets Kepler 80g and Kepler 90I, located in the Kepler 90 star system in the constellation Draco. "It's like searching for a needle in a haystack," said Chris Chalou, a senior engineer at Google AI and one of the project researchers during a press briefing at the time of the discovery. By October 2018, Kepler ran out of fuel and ended its mission. But even after the telescope stopped hunting for new worlds, scientists continued analyzing its data, combined with information from the Gaia telescope, and discovered another 104 exoplanets. To reach that level of accuracy, the team trained their algorithm on NASA's datasets. After learning from 15,000 test signals, the system was able to correctly identify planets 96% of the time. At the Japan Aerospace Exploration Agency, or JAXA, engineers developed INT-BALL, a small, remotely operated drone that records experiments aboard the International Space Station and sends the footage back to Earth. All components of INT-BALL were 3D printed. It navigates using 12 small propellers and orients itself by tracking bright pink markers placed throughout the ISS. This tiny camera-equipped robot, weighing just 1 kilogram and measuring 15 centimeters in diameter, helps synchronize the work between the crew on board and teams on the ground. INT-BALL has already taken over some astronaut duties, reducing their workload by about 10%. In the future, INT-BALL is expected to monitor supply levels and even assist in repairing damaged equipment. Modern AI systems are making space software and hardware more autonomous, capable of learning and adjusting without constant human input. Some of the most anticipated developments in this area are spacecraft that can correct their trajectory, operate on autopilot, and land themselves on space stations or planetary surfaces. AI is also helping NASA develop concepts for interplanetary landing modules. Choosing a landing site is a complex task. The surface must be relatively flat, sunlit, if the spacecraft relies on solar power, and scientifically interesting. The area also needs to be large enough to allow for deviations during descent. The problem is, these decisions must often be made based on incomplete and varied data collected from multiple sources. To solve this, scientists created an AI system based on fuzzy logic, a framework where statements can be partially true instead of simply true or false. In fuzzy logic, you might say a location is likely suitable rather than just yes or no. The system analyzes data about terrain, atmosphere, soil composition, and more, dividing the Martian surface into small segments. Each segment is scored from 0 to 1, where 0 means unsuitable and 1 means ideal. It then groups favorable areas together and presents them to scientists for review. The same method could work in reverse too, choosing the right rover for a specific terrain type. Eventually, systems like this could be used to build autonomous rovers that contact Earth only in emergencies, speeding up planetary exploration dramatically. One of the greatest risks for astronauts in space is radiation. During a mission, crews are exposed to two main types of ionizing radiation: solar flares and galactic cosmic rays. Prolonged exposure can break DNA strands. Although the body can repair some damage, these repairs aren't always perfect and may lead to dangerous mutations. To address this, scientists around the world are working on AI systems that continuously monitor astronauts' health. The goal is to detect even the smallest changes in the body so that any threat can be spotted early and countermeasures taken before it's too late. Such technology could be crucial for long-duration missions, especially to the Moon, Mars, or beyond. Space missions are also psychologically challenging. Being far from Earth, family, and familiar routines for months at a time is hard, even for trained astronauts. That's why scientists are exploring how AI can offer emotional support too. Simon, the Crew Interactive Mobile Companion, was developed by Airbus and IBM for the German Aerospace Center. It's a floating AI assistant that looks like a small robotic ball and can interact with astronauts on the ISS. Simon is equipped with cameras, microphones, sensors, and processors. It can navigate in any direction using built-in fans, nod in response, and recognize faces. Its main job is to assist with complex tasks by providing step-by-step instructions or locating technical information. But Simon also has a social role. It can hold basic conversations, respond to voice commands, and display a friendly animated face on its screen. The idea is simple. Even a small social connection in space can make a difference. In Russia, researchers are developing humanoid robots designed for rescue missions in space. One of the most advanced examples is FEDOR, short for Final Experimental Demonstration Object Research. FEDOR can drive a vehicle, climb over obstacles, operate tools, and carry loads up to 20 kilograms. It's the only humanoid robot so far that can crawl on all fours. To interact with its environment, FEDOR uses cameras, a thermal imager, a microphone, GPS, and dozens of laser sensors. This equipment allows it to map its surroundings in 3D and perform precise tasks. FEDOR operates in several modes: autonomous, supervised, copy control, and hybrid. In copy control mode, an operator wears a special suit that mirrors the robot's movements and even receives feedback on things like weight or resistance. In 2018, FEDOR was handed over to Roscosmos, where it began preparations for spaceflight. Artificial intelligence has become a vital part of space exploration, not just a helper, but a real tool. It doesn't replace the human mind, but it can do what we simply can't: process billions of data points, detect anomalies, sort, compare, calculate. Modern astronomy is about volume. Telescopes like James Webb, Gaia, TESS, and Hubble generate terabytes of information. Thousands of images, millions of spectra, light curves, and signals every single day. There's just no way to review it all by hand. That's why astronomy relies on algorithms and increasingly on AI. Kepler and TESS, for example, monitor the brightness of stars. When a planet passes in front of its star, the light dims ever so slightly. These tiny changes, AI can catch them. It scans thousands of light curves and flags anything that looks like it might be a planet. That's how Kepler 90I was discovered, a planet no one expected. A human might have missed the signal, the algorithm didn't. AI is also helping with gravitational waves. Detectors like LIGO register subtle distortions in spacetime, but the signals are weak and often lost in noise. AI helps filter out the background and react quickly when something real appears. It's even involved in the search for extraterrestrial signals, in projects like SETI and Breakthrough Listen. These programs analyze millions of radio transmissions. AI sorts through them, cuts out repeating patterns, and highlights anything strange. In 2023, a neural network found 8 anomalous signals that had been overlooked before. And now scientists are giving them a second look. Sometimes AI finds things by accident. In Gaia's archive, it identified a new star cluster that human astronomers had missed. The data was just too vast to spot it manually, but the algorithm saw the pattern, and astronomers later confirmed it. Soon, we'll see autonomous telescopes deciding where to look on their own. AI will track bursts, transits, and flares in real time, and alert scientists immediately. These systems already exist in testing, and they're working. AI is also heavily used in modeling. It simulates galaxy formation, dark matter flows, black hole behavior. These simulations help test theories faster, sometimes reducing years of work to just weeks. And if someday there's something truly unusual hidden in the data, it may not be a human who notices first.